Hi everyone. Good morning to everyone. We are going ahead and starting the session. So, before the session is starting, I'll give you a short introduction about myself and the speaker. So, I'm Kirti, and I hold a master's degree in computer science at Northern Illinois University. And I have around 5 years of experience as a business analyst, including the companies I worked for are like Capgemini, Amazon, and Forces. So it is a pleasure for me to be hosting today's session and introducing our speaker. So our speaker today is Harpreet Siddhu, a lead software engineer and a cloud solution architect with over 18 years of experience in enterprise solution development. Harpreet is also an AWS community builder and an AWS reInvent 100K hackathon champion, known for his work in serverless architectures and Gen AI enabled workloads. Throughout his career, he has led large scale cloud modernizations initiatives, successfully migrating mission critical applications to AWS, reducing operational costs, and improving systems and compliance in highly regulated environments. Harpreet is also an early adopter of generative AI, and his recent work focuses on an increasingly important topic in the industry: how we test and validate AI systems responsibly as organizations rapidly adopt AI driven tools. So, today he will be sharing insights on this evolving space and how teams can balance innovation, speed, and reliability when building AI powered systems. So, please join me in welcoming Harpreet Sidhu.
Thank you, Kirti, for the introduction. Good morning, everyone, and thank you for having me at TestFormation 2026. My name is Harpreet Siddhu, and I'm a lead software engineer and AWS community builder. So today, I want to talk about a problem that we are facing with AI agents in testing. As AI agents become capable of writing and testing our code, we face a very simple but very important question, like who will validate the validator? So let's dig in and understand this problem and the strategies to solve this. So let me start with something we all understand. Think about your school days when your teacher asks you to do your maths homework, and then she asks you to grade your own paper. What will happen? You probably will give yourself a pretty good score, right? Now, this is not because you are cheating, but because you genuinely cannot see what you got wrong. Your mistakes are invisible to you because it's your brain that made those mistakes. And now the same brain is checking them. And this is exactly what is happening in software testing with AI agents. The same AI writes your application code and writes the test for that code. And if the AI doesn't understand a particular bug or edge case in the code, it isn't going to write the test to catch that bug either, right? So in the current world, basically, we have automated the testing, but we have not automated test validation. And that's our paradox. Now, this is not just me making some theoretical arguments here. Let me show you a real experiment conducted by a UK consulting firm called Nimble Approach. They ran a controlled study in which they took a Python module and they asked GenAI Assistant to generate the initial test cases for it. At first glance, the results appeared promising. AI created 12 test cases and achieved about 85% code coverage. But later, they ran the mutation testing, which I will tell you shortly what exactly it is. Their mutation kill rate was only 57%. In other words, nearly 43 simple single fault bugs that were intentionally introduced into the code went undetected. The tests were passed, but they failed to provide meaningful validation of the underlying logic. Later, human testers were introduced into the experiment, and they guided the AI by giving specific feedback like you missed this boundary condition or this particular edge case is not included. And after the feedback, the test suite grew to 33 tests and caught 80% bugs. So, what did we learn from this experiment? We learned that the same AI helped us getting better results with human guidance. And now let me ask you this question. Why does this happen? Like, why do AI test looks correctly initially, but missed out the real bugs? And for that, let me give you a simple analogy. Imagine you ordered a pizza and you submit the order online, and the screen says order placed. Now you're happy and waiting for your pizza, but the system never actually called the kitchen. So no pizza is being made and no pizza arrives. So AI tests do exactly the same. They check the return value, which is order placed in this situation, but they never check if kitchen was actually called, right? Which is the behavior. So AI is trained to verify the output. It doesn't understand the context within the order method in this case unless you provide that, right? So this is the problem with the AI test that we write and we test. Now there are three specific patterns I have seen. First, AI checked state, not behavior. It verifies what function returns, but it never checks if the right dependencies were called. Second, it completely ignores side effects. In the Nimble approach experiment, 45% of the gaps came from untested logging, counters, and audit trails. Now, these are the things that don't affect the return value, but they are critical for the production systems because you add loggings, audit trails so that you can do debugging and later root cause analysis. And if you are not testing these things, you might not able to do debugging and root cause analysis later on. Third, it misses the edge cases. For example, AI will test with empty strings, but it will not test for null values or missing dictionary keys or different boundary conditions. And for that, you need to provide the context to the AI so that it can write those tests for you. Now, I want to tell you a real story here, which will make this very concrete. In July 2025, Jason Lemkin, the founder of SaaStr, one of the biggest SaaS community in the world, spent 9 days building a contact database with Replit's AI agent. Now, this was a real business tool. He had around 1,200 executive contacts and around 1,190 business companies' information in that system. Now, when the app was working fine, he put that app on the code freeze. He explicitly told AI, "Don't touch anything without my permission." But at some point of time, some queries started returning empty results, and then AI decided that there is something wrong with the system. Now, without human approval, it ran database operations that wiped out the entire production database. Every single contact gone from the database. But it get worse. When Lemkin asked AI if he could roll back those changes, AI said rollback was not possible. And that was a lie because rollback was possible that time. Cherry on the top, before this whole disaster, the AI had quietly been creating fake data about 4,000 fictional contacts to cover up earlier mistake that it had made. So what was the root cause here? The problem was that there was no separation between development environment and production environment. There was no approval gate for destructive actions. The AI had full autonomy and with absolutely zero oversight. Now, I want you to keep this story in mind because every single solution that I'm about to show you today would have prevented this entire disaster. Now, Replit story is dramatic, but it is not an outlier. This is a pattern across the industry. Carnegie Mellon and Salesforce found that AI agents fail on roughly 70% of real world tasks. Gartner predicts that over 40% of AI agent projects will be cancelled by 2027. And yet, 57% of companies already have AI agents running in production, as per the G2 survey. Now, why I'm saying this? And what we are doing here, like I want to say that we are deploying agents faster than we are learning how to validate their work. Now, through my research, I have identified three strategies that work together as a system. First one is the mutation testing. It's like testing a lock with wrong keys, and if lock opens, It's not a log that you can trust. Second is hotspot prediction, which means that you focus your AI on risky part of your code instead of testing everything equally. Third, most important, governance. And this is the strategic human oversight that scales trust without managing the AI. Now, let me walk you through each one of these with hands of example so that you can get more idea on how to use these strategies and implement them in your systems. Mutation testing. So think of mutation testing is like a fire drill. So fire drill is like intentionally triggers the alarm, not because there is a real fire, but to check if people know how to evacuate. The same principle applies with mutation testing. Here you intentionally break your code to check if tests that you know or you have know how to catch the bugs. And here is how it works in simple steps. So step one, you introduce small code mutations. For example, you can change greater than equals to greater than. You would change true to false, or you would change plus to minus. And these are called the mutants that you introduce intentionally in the code. Step two, you run your existing test suite against these mutants. Now, if test fails, that's great. You caught the bug and you killed the mutant that you have added. But if test still passes, that means your test has a gap and the mutant survived. In the step three, you will calculate the kill rate, which is the percentage of mutant caught. And that becomes the real measure of your test quality. Now, let me show you an example of how exactly this looks like in practice. So here's a simple function is eligible, and it checks like if age is greater than or equals to 18. Now let's run the mutation testing on this code. And once you run it, it will add a mutant that will change the greater than or equals to just greater than. After this, we will run the test again. The AI test is using age value as 25. Now, does 25 will pass both versions? Yes, because it will return true because we are checking for value 25. The mutant will survive. The test looks correct, but it missed a real boundary condition. So what will be the better test? The better test is to test with age exactly 18. With the original code, the test with value 18 will return true, but with the mutant code, it will return the false, which means the mutant is killed and our test suite is failing. So now one test at the boundary and suddenly your suite is more meaningful and stronger. So what did we learn from here and how we should approach the mutation testing? So this is the feedback loop that I want you to remember. The step one is basically to let your AI generate tests for you. In step two, you will run mutation testing. And in step three, use the mutation report to write better prompts for the AI. You can say that the mutation showed that changing greater than equals to greater than was not caught. Please write a test that checked the boundary value of exactly 18. And this is just a simple example, but this is how you can work with AI to write test cases to kill mutants in your code. So here AI does the typing for you, you do the thinking, and this is the right division of labor basically. And the results speak for themselves. Like Nimble approach experiment found out that this strategy helped them to get 40 to 50% faster quality test coverage than traditional test driven development. One more important thing that I want to share is that Meta uses this strategy at scale. They have a tool called ACH, or Automated Compliance Hardening, which they have introduced early in 2025. And it uses large language model to identify potential bugs by creating mutants in the source code and then automatically generating tests to detect those specific security and privacy issues. They use ACH for platform like Facebook, Instagram, and WhatsApp with 73% text acceptance rate. This test acceptance rate is basically their kill rate. And these tools are available for different workloads. So for example, for Python you can use Mutmut. Striker is another tool which is available for JavaScript, TypeScript, and C# programming language. And then PIT, which is PIT, this is for the Java workloads. All these tools are open source and free to use. Second one is hotspot prediction. Now here I would like you to think hotspot prediction like a health inspector. Now, do you think it is possible for a health inspector to inspect each and every restaurant, how big or small they are in the city with equal effort? No, right? Because it will be a waste of time and energy. Instead, what they do, they focus on ones with recent violations, new management, or lots of complaints. Now, same principles applies here. In your code, you don't have to basically write exhaustive testing for all the files, because not all files in your code base are equally risky. Some files change constantly and they attract bugs, and they need deeper testing. So there are three signals that predict where bugs actually live. First one is code churn. So these are the files with lots of line added and deleted. Second one is change frequency, like files modified how many times. For example, you are modifying that file for 127 times in 6 months. That's a high risky file. And third is commit message, where you see bug fix or fixing this problem, similar to that. So these are the things where you can see more bugs. And these patterns are called hotspot, which are the part of your code base where bugs are more likely to live. Now, Facebook takes this to extreme. They use over 50 variables, including change frequency, developer experience with that file, and complexity metrics to guide their test selection. Now, as a result of that, they run 50% less tests with same bug detection rate, which is quite amazing, right? Now, finding bug hotspot on your code is not difficult at all. You can just try this today as well with zero new tools, and just by writing like or running one git command. The command that I'm showing you on the screen looks for the last 6 months of git history and counts how many times each file was modified. Then the file at the top are going to be your hotspot. Take those 10 to 20 files and feed them to your AI with targeted prompts. You can prompt like generate comprehensive test for these high churn files, focus specifically on boundary conditions and error handling paths. The AI can generate deeper, more targeted tests where they matter the most. Then with this approach, you are basically doing the limited testing but with biggest impact. Next is governance, your most critical safety net, which adds control gate so human can stay in charge. And here's the analogy that I want you to remember. On a nuclear submarine, one person cannot launch a missile by themselves. They need dual control, two people turning keys at the same time. And this is not because they don't trust their crew. It is because the consequence of making a mistake are too high if you leave it to single point of failure. AI agents need same principle. AI agent needs approval gates for high risk actions and monitoring for everything else. Now, before we look more about governance, look into like how it looks in practice. Let me explain why it is critical and it's like how the compounding error problem works. So think about the telephone game. You know the game, right? You whisper a message through a line of people, and let's say the person get the message 95% right. Now, by the time the message goes through 20 people and it reaches to end correctly only 36% of the time, the 5% error rate at each step compound into 64% total failure rate. And this is simple mathematics. Now think about what AI testing agents actually does. It just does not take like one decision for you. It decide what to test, pick the test type, generate the code, runs it, and interprets the results, and maybe modify your code base. And this is a chain of like 10, 15, 20 or more decisions. And if decision is 95% correct, after 20 decisions, you have like 64% chance that something will go wrong. And this is why governance matters. Every checkpoint you add, it will break the chain and reset the error accumulation. So from 20-step chain with 64% failure to 5-step chain with 77 success with human checkpoint is what you can do with governance. Now we know that how to reduce the compounding error problem by placing governance and checkpoints and breaking that AI decision chain. But thing is, do you really need this for everything? But answer is, it depends on risk and complexity. Now there are two governance models that you can follow. First is human in loop, where AI pauses, human approves, then AI continues. And you can use this particular model for high risk actions. Like if you have something like authentication workflows or payment workflows, database operations where you need human involvement. Second is human on the loop. Here AI runs autonomously and human monitor the progress and intervene only when it's needed. This can be used for low risk tasks like when generating unit test, or doing some formatting changes with AI, or routine regression task or something like that, where you can let AI to work and then you can intervene if you see something is going off. And here are 4 patterns that can make governance very practical, which you can start implementing in your next AI project. Number 1, approval gate. Like define which test decision need human sign off based on the risk level. For example, AI is modifying tests for the login flow or payment system. So here, yes, you need to review this because it's a critical path for you. And for AI, if updating like UI color or just changing the text label, so you can probably, you don't need human approval here. So think about risk level and based on that, see if you really need approval gates. Second, escalation triggers. Here you set up automated alerts for things when they go off. For example, your mutation kill rate drops below 70%. So you need an alert for that. Test flakiness suddenly spikes. You need an alert for that as well, because these are your smoke detectors. The idea is to catch problem before it can spread and cause major failure later on. Number 3 is override protocol. This means clear documented procedures to pause the agent, roll back its changes, or direct its focus. When things go wrong, you need a plan that is already written down, not the one which you will invent in the middle of the crisis. Number 4 is audit trail. Log every AI decision, what it is doing, what it is testing, what it is skipping, why it is doing that. And it is not just for debugging, it is like for learning. Over the time, these log will tell you where your AI is strong and where it need more guidance. Now remember the Replit story which I told you. Now any one of these patterns would have prevented the Replit incident. An approval gate would have stopped the deletion. An escalation trigger would have caught the data corruption. An override would have rolled back the changes. An audit trail would have caught the fake data creation early on. So now putting this all together, what I want to share is like how to approach this system and apply in real practice. So first of all, first step that you have to do is to identify your hotspot. One git command that you can run and you will know 20 risky files from your system. Then point your AI at those hotspots with targeted prompts. The purpose is to focus on deep testing where it matters most. Then run the mutation testing on those generated, like whatever test AI generates, run mutation testing on that. Mutation testing tool will expose the gaps and give you the honest kill rate. Next, feed those gaps back to AI with specific prompts. For example, like the boundary condition was not tested, this behavior need more targeted test, and then repeat this process until you get kill rate up to 70 to 80%. And in step 5, deploy with governance in place, put human approval gates based on the critical paths, and generate audit trails for everything. Like if you try this total setup will not take like more than 1 hour. After this, you can automate the hotspot analysis and mutation testing in your CI/CD pipelines, and then it will run on its own for every pull request. So in the end, I would like to say that with AI agents, we need to shift from measuring execution to measuring verification. We need to use kill rate as the quality metrics instead of like code coverage. We should use hotspot driven testing instead of like uniform distributing tests, and add governance into your testing architecture from day one. There should not be any thought for that. Like it should be the part. It should be the part of the testing from the day one. And here is their toolkit that you can use. Everything that I have shown today uses open source tools and free and ready to use. I have also prepared a complete demo projects which you can clone from my GitHub repository. The link is provided in the handout. It includes AI generated test along with mutation hardened test, the hotspot analyzer and the governance checker script, and a CI/CD pipeline workflow as well. You can try that out and you can get some hands-on experience to learn how to implement these strategies in real-world projects. The handout has everything, all commands, the complete checklist, and research sources for your further reading. Thank you so much for your time today. I would encourage you to try these strategies, and I promise you that you will learn something new about your test suite. If you have any questions, I'm happy to take them now. Thank you.
Thank you so much, Harpreet, for that insightful session of yours. So we are already past time, but I think we can take one question. So like we have a couple of questions, but maybe you can combine those questions and give an answer. So let me read out the questions. So the first question is, doesn't mutation testing take too long to run on a large code base? And the second question is human in the loop governance realistic for teams shipping fast?
Yeah, so yes, mutation testing can take longer time if you will run it for the whole complete code. But remember that I showed you one slide where I put together everything and I showed you a real uh, uh, way to implement these strategies. So you don't have to run mutation testing on the complete code base to save time. Instead, you need to first run the hotspot prediction to find out what are the risky and most impacted file from your code base, and then just run the mutation testing on these targeted files, which can speed up the process. And also, when you implement and integrate these things within your CI/CD pipeline, it will help you to complete those pipelines faster. So yeah, I mean, it will take time, but you need to be little strategic here. Use hotspot prediction, figure out important files from your source code, and then run mutation testing on that. And if you have Python based workloads, then the tool like Mutmut, it allows you to run mutation testing on a specific file also, like one single file. You can provide that in the configuration, and you can just run mutation testing on one single file as well. So for someone who is developing and writing a code, and say they are adding code in 4 or 5 files, you can run your mutation testing on those specified files within your code base as well. So that way you can speed up. And regarding second question, if you're moving faster, so yeah, I mean, this is something which will kind of take little time, but again, without governance and without if you give total autonomy to AI agents, what happened with Repellate can happen with you as well. So you can have 80% of tasks done by the AI agents, but that 20% you need to keep with yourself, and have your AI like control those actions in that 20%, so that you can avoid the disaster which can happen in future with your application. So there are some trade-offs. You need to basically think about it and decide based on your priorities and how fast you are moving with your with your system and with your development basically.
Sure. And I see in the chats that people are asking for GitHub link and the handout material. So is it handy with you to share it in the chat or the handouts thing? Because I know you shared the handout with me, but I don't find I'm able to share the handout here.
Let me see, like I don't know how to share it. Let me share the GitHub repository quickly here. I have that available.
And maybe for the handouts, maybe people you can reach out to Harpreet on his LinkedIn so that he can help you in sharing the handouts.
I just sent this in the chat. I hope you get it.
Yes, we got it.
Okay.
Yeah.
Yeah, I will probably put the handout also in the Git so that people can get it from there.
Yes, that's helpful. Thank you. Okay, we are past 3 minutes of the session, and thank you so much, Harpreet, for this wonderful, insightful session. And we have gained much more knowledge on the topic. So, thank you so much. Thank you,
Thank you.
everyone, for participating. Thank you. Bye bye.